Hello everyone, my name is Dr. Zeroth Khan, and today in numerical analysis course we will discuss divided differences. So what are divided differences? We will introduce the divided differences methods. What are divided differences? These are the methods that are used to successively generate interpolating polynomials. So if we want to generate interpolating polynomials, we can use the divided difference methods. So for instance, if we suppose that Pn of x is the nth Lagrange polynomial, then for the given data points, n plus 1 data points, x0, f of x0, x1, f of x1, up to xn, f of xn of the function f of x, when the Pn xi is equals to f of xi for I from 0, 1 up to n. Now the same interpolating polynomial can be written in general form as Pn of x is a0 plus a1 x minus x0 plus a2 x, so let's say a2 x minus x0 x minus x1 x and an x minus x0 x minus x1 and x minus x minus 1. Now we can find out excuse me, the a0, a1, a2 and an terms by putting values in x I, f of xi. So if we put x not here, then this becomes x0, right, in this one, and we have a 0 plus all the remaining terms for x. If we put x naught, all the terms become 0 except x naught. So we get p naught, pn of x naught is a naught, and pn of x naught from this would be Pn of x naught would be then from here f of x naught. So this gives us a naught would be f of x naught. And similarly, we can find out that a1 is given by f of x1 minus f of x naught over x1 minus x naught, and so on. Now what we need is to write this down in the divided differences notation. So how do we write that? The general notation of divided difference notation is Pn of x is f of x naught plus summation k from 1 to n f of x naught comma x1 to xk into x minus x naught into x minus x1 into x minus x k minus 1, where f of x I in general is equals to f of xi. This is called the zeroth divided difference. So that means that we can find out for any particular x, we can find out this one, we can find out this one, we can find out any particular value. Similarly, the first divided difference is given by f of x1 xi plus 1 is given by xi plus 1 minus xi. Remember that these are denoted by the square brackets. Xi plus 1 minus f of xi, and this is with respect to xi, and this is with respect to xi plus 1 and xi. So it means we can find out x0, x1, we can find out x0, x2, we can find out x1, x3, any 2 points, x1, x3, and so on. Similarly, we can find out second divided difference, third divided difference, and so on. So the kth divided difference with respect to xi plus 1 up to xi plus k is given by f of xi plus 1 up to xi plus k is equals to f of xi plus 1 up to xi plus k minus f of xi up to xi plus k minus 1 divided by xi plus k minus xi. And now when we put all these values in the first equation, which was this one, summation k is equals to 1 to n f of x naught to xk and x minus x naught, then we get Pn of x is equals to x naught plus f of x naught comma x1 x minus x naught plus f of x naught x1 x2 into x minus x naught x minus x1 plus so on, and then f of x naught x1 to xn into x minus x naught and x minus xn minus 1. So this is the formula that is used to find out the interpolating polynomial using the divided difference methods. So in the next lecture we will use an example of different data points would be given, and we will use the divided difference methods and using this formula to find out the interpolating polynomial. Thank you very much.